Have you ever pondered about how your smartphone recognizes your voice, or how your email has the intelligence to differentiate between spam and legitimate emails? These are the marvels of neural networks, the wizardry behind machine learning. In this era where technology reigns supreme, the know-how of neural networks isn't reserved only for tech gurus, but is an absolute necessity for all, from novices to executives. Though neural networks seem to be a concept, they're really not. Imagine them as digital brains with a network of interconnected neurons, all functioning in sync to process data and make decisions. Their pivotal role in constructing intelligent systems that influence our world today is undeniable. Their impact is evident in a broad range of industries, from marketing to healthcare, where they streamline targeting strategies, assist in disease diagnosis, and accomplish much more. So whether you're a tech aficionado or an executive exploring practical knowledge, it is crucial to understand neural networks. In this video, we demystify the intriguing world of neural networks, ensuring it's easy and comprehensible for all. And before we sign off, do remember to hit the subscribe button for a Demystify Tech to keep receiving more tech insights. So, what exactly are neural networks? Well, let's dive in to answer that question. Neural networks, as their name suggests, are inspired by the human brain's neural network, a complex system of neurons that communicate and work together to process information. Similarly, in the world of technology, neural networks are systems of interconnected artificial neurons, or nodes, that process information in unique and innovative ways. Picture it this way. Imagine a colossal network of virtual neurons, each connected to others, forming a vast and intricate web. Each of these neurons is capable of receiving, processing, and transmitting information, just like the neurons in our brains. These networks are designed to recognize patterns. They interpret sensory data through a kind of machine perception, labeling or clustering raw input. The patterns they recognize are numerical, contained in vectors into which all real-world data, be it images, sound, text, or time series, must be translated. Sounds fascinating, right? Now, you might be wondering, how do these neurons work together? Well, they are organized into layers. The first layer receives the raw input, similar to our senses receiving information from the environment. The final layer provides the output, akin to our brain producing a response. Between these two layers, we have what we call hidden layers. These layers perform complex computations and transform the input into something the output layer can use. The real magic happens within these layers. Here, the data is processed through a series of weighted connections and bias, then passed through an activation function. This function decides whether a particular neuron will be activated or not, determining the output of that neuron. So in essence, neural networks are the engines that drive intelligent systems. They mimic the human brain's functionality, enabling machines to learn from data, recognize patterns, and make decisions. And just like our brains, which continue to learn and adapt over time, these networks also learn and improve, becoming more accurate and efficient in their tasks. That's a basic overview of neural networks. But we're just scratching the surface here. There's so much more to explore and understand about these fascinating systems. Let's break down the components of a neural network. To understand neural networks, it's crucial to grasp the core elements: neurons, layers, and activation functions. So let's start with neurons. Think of neurons as the stars of the show. They are the basic units that make up the network, like tiny decision makers. Each one takes in several inputs, processes them, and produces an output. Now, imagine a group of these neurons. They can't just be scattered around. They need a structure, right? That's where layers come in. Layers are like teams of neurons working together to process information. We can typically categorize these layers into three types: the input layer, hidden layers, and the output layer. The input layer receives raw data, the hidden layers process this data, and the output layer provides the final decision or prediction. But how do these neurons decide what to output? That's the role of activation functions. Picture activation functions as filters. They decide whether a neuron should be activated or not, based on the inputs it receives. They help the network make sense of complex patterns by adding non-linearity to the mix. This means they allow the network to understand not just straight-line relationships, but also more complicated curved relationships between variables. Let's make this a bit more tangible with an example. Imagine you're at a music festival trying to decide which band to watch next. Each band playing is a neuron. The stage they're playing on represents the layer, and the type of music they play is the activation function. You'll choose the band based on your preferences, just like a neural network chooses which neurons to activate based on its activation functions. So in essence, neurons are the decision makers, layers provide the organization, and activation functions determine the output. These three elements work together to form the backbone of a neural network. They are like the cogs in a clock, each playing a vital role in ensuring the clock runs smoothly and accurately. Together, neurons, layers, and activation functions form the backbone of any neural network. Now let's talk about two core processes in neural networks: feedforward and backpropagation. Dive into the world of neural networks, and you'll frequently encounter these terms, but what exactly do they mean? Let's break them down with some simple analogies. First off, feedforward. As the name suggests, it's all about moving forward. Think of it like a relay race. The information, or the baton, starts at the input layer, the first runner. Each subsequent layer of neurons, our team of runners, takes the baton and computes the next step, passing the information to the next layer. This continues until the baton reaches the output layer, the final runner, where the result is produced. That's feed-forward, a one-way flow of information from input to output. Now, on to backpropagation. This process is a bit more complex, but equally important. Backpropagation is like a teacher grading a test. The network makes a prediction. That's the student taking a test. The prediction is compared to the actual answer, the grading process. The difference between the predicted and actual answer is called the error. This error is then used to adjust the weights of the network, akin to a student learning from their mistakes to perform better next time. Essentially, backpropagation is the network's way of learning from its errors. It adjusts its internal parameters, or weights, based on the error it made, just like how we learn from our mistakes. Together, feed-forward and backpropagation form the heart of a neural network's learning process. Feed-forward moves the information through the network, producing an output. Backpropagation takes this output, compares it to the actual answer, and adjusts the network's parameters accordingly. It's a continuous cycle of prediction and learning, of moving forward and looking back. In the grand scheme of things, these processes enable neural networks to make accurate predictions, recognize patterns, and learn from their mistakes. They are the reason why neural networks can perform complex tasks and make intelligent decisions. Feed-forward and backpropagation are essential for a neural network to process information and learn from mistakes. So, where do we encounter neural networks in business, you may be asking? Well, the answer is pretty much everywhere. Let's discuss some real-life examples where neural networks are actively reshaping industries. Let's start with marketing. In this digital age, marketing has evolved beyond catchy slogans and eye-catching visuals. Today, it's all about data, and neural networks are the champions of data processing. They help businesses understand customer behavior, predict trends, and optimize ad targeting. Consider a company that sells fitness gear online. By using neural networks, they can analyze customer data, predict who is most likely to buy their products, and target those customers with tailor-made ads. The result? Increased return on investment and happier, well-served customers. But it's not just marketing. The finance industry is another area where neural networks are making a significant impact. They're used for credit scoring, fraud detection, and algorithmic trading. Suppose a bank wants to determine a customer's creditworthiness. Neural networks can analyze the customer's financial history, employment status, and other relevant data to predict their ability to repay loans. This speeds up the loan approval process and helps the bank reduce the risk of bad debts. Moving on to healthcare, a sector where accurate and timely decisions can mean the difference between life and death. Neural networks are used to analyze medical images, predict disease progression, and even help in drug discovery. Take, for instance, a hospital using a neural network-based system for diagnosing skin cancer. The system can analyze thousands of skin images, learn patterns associated with malignant and benign conditions, and assist doctors in making accurate diagnoses. In the retail sector, neural networks are transforming the shopping experience. They're used for inventory management, demand forecasting, and personalized recommendations. Imagine walking into a store that knows exactly what you want. That's not science fiction. It's happening now, thanks to neural networks. The transport industry isn't left out either. Neural networks are at the heart of self-driving cars, optimizing routes for logistics companies, and predicting maintenance needs for vehicles. Consider a logistics company that uses neural networks to optimize delivery routes. The system can analyze traffic data, weather conditions, and delivery deadlines to suggest the best routes for drivers. This not only saves time, but also reduces fuel consumption and carbon emissions. And let's not forget about entertainment. Neural networks are used in video games for creating more realistic non-player characters, in music for composing new tunes, and in movies for special effects. So, whether it's marketing, finance, healthcare, retail, transport, or entertainment, neural networks are playing a crucial role. They're helping businesses make better decisions, deliver superior customer experiences, and stay ahead in this hyper-competitive world. As you can see, neural networks play a crucial role in numerous industries. They're not just a fancy tech buzzword, but a powerful tool that's driving innovation and growth. And that's why understanding them is essential for anyone who wants to thrive in today's business landscape. Imagine a world without neural networks. How would that affect businesses? In this ever-evolving technological landscape, it's quite a thought to ponder, isn't it? To truly appreciate the value of neural networks, let's delve into a few hypothetical scenarios. Consider a marketing team tirelessly working to optimize their ad targeting. Without neural networks, how would they predict the right audience for their ads? Would they be able to anticipate customer preferences accurately? Or would they be shooting arrows in the dark, hoping to hit the right target? Now let's shift our focus to healthcare. Picture a world where disease diagnosis relies solely on traditional methods. Without neural networks aiding early detection, would we be able to promptly identify life-threatening conditions? Or would we lose precious time waiting for symptoms to manifest before we can act? And how about finance? In a world devoid of neural networks, would our financial systems be able to detect fraudulent transactions swiftly? Or would we be left vulnerable to scams, losing hard-earned money to crafty fraudsters? Think about the logistics industry. Without neural networks, how efficient would our supply chain management be? Could we predict demand, manage inventory, and ensure timely deliveries effectively? Or would we grapple with overstocking, understocking, late deliveries, and unhappy customers? These questions, while hypothetical, bring to light the immense value neural networks bring to various sectors. They underscore the significance of these virtual brains in enhancing efficiency, improving accuracy, and ultimately driving business success. But remember, with great power comes great responsibility. As we harness the power of neural networks, we must also consider ethical implications. How do we ensure data privacy? How do we prevent misuse of this technology? These are equally important questions that require careful thought and action. The implications of a world without neural networks are profound, highlighting their importance. So, as we continue our journey into the world of neural networks, let's appreciate their value, understand their potential, and consider the ethical implications. The future of business, and indeed our world, depends on it. The importance of integrating neural networks into your business strategy cannot be understated. Overlooking these mighty tools can result in grave repercussions. Consider neural networks as the co-pilots for businesses, sailing through the ocean of vast data, identifying hidden patterns, and making pinpoint predictions. The absence of such a tool leads businesses into a potential pitfall, where they miss out on unearthing valuable insights and gateways for growth, innovation, and establishing a competitive edge. The benefits of neural networks extend beyond just data processing. They also enhance efficiency and productivity. They take over the monotonous tasks, liberating human resources to focus on more strategic tasks. Therefore, if businesses are to maintain their competitive edge and operational efficiency, they must welcome the power of neural networks. That brings us to the end of our journey into the world of neural networks. We've demystified the essence of neural networks, painting them as virtual brains teeming with interconnected neurons. We've dissected the anatomy of these networks, exploring the crucial roles of neurons, layers, and activation functions. We've also delved into the mechanisms of feed-forward and backpropagation, the driving forces behind these intelligent systems. Further, we've bridged the gap to real-world applications, underscoring the transformative impact of neural networks across industries. Through thought-provoking questions, we've stimulated critical thinking about a world without these advanced technologies. And we've underscored the dire consequences of overlooking neural networks in business strategies, highlighting the potential loss of competitive edge, operational inefficiency, and missed opportunities. Thank you for joining us in this exploration of neural networks. We look forward to seeing you in the next module. Please subscribe to our channel at Demystify Tech.